subject is about authorities having jurisdiction or odds requiring additional nail plates to protect a non-metallic sheath cable or NM cable where it crosses horizontal furring in truss areas, citing National Electrical Code Section 300.4. An incident occurred where a nail plate pressed into the NM cable, energizing the vapor barrier and corner bead and causing an electrical shock to a child. Concerns were raised about the potential hazards of this additional nail plate protection, and the authorities having jurisdiction were called to report the incident. As a result, the authorities having jurisdiction rescinded the requirement for additional nail plates in this area. The incident described illustrates how additional nail plates can puncture NM cable, creating an electrical hazard. If the nail plate becomes energized, it can transfer electricity to other materials, such as vapor barriers and corner beads. This can pose a significant shock risk to individuals who touch these materials. Electrical contractors should be aware of the potential hazards associated with additional nail plate protection in truss areas. They should carefully inspect any areas where NM cable crosses furring and ensure that nail plates do not puncture or contact the cable. If additional protection is needed, alternative methods should be explored, such as using cable guards or running the cable outside of the truss area. Authorities having jurisdiction should reconsider the requirement for additional nail plate protection in truss areas given the potential hazards. Electrical inspectors should carefully examine these areas during inspections and identify any installations that may be unsafe. Homeowners should be educated about the potential risks and should promptly report any electrical shocks or other electrical hazards. This situation highlights the importance of adhering to the National Electrical Code, or NEC, while also recognizing the potential unintended consequences of well-intentioned safety measures. The National Electrical Code Section 300.4 addresses protection against physical damage. It generally requires that cables and raceways be protected from physical damage where they pass through wood or metal framing members. This is often achieved by using nail plates, which are metal plates that are installed over the cable or raceway to prevent nails or screws from penetrating it. While nail plates are effective in preventing physical damage, they can also create electrical hazards if they are not installed properly. If a nail plate is installed too tightly, it can puncture the cable, exposing the conductors inside. If the nail plate then comes into contact with a grounded object, such as a metal stud or a water pipe, it can create a short circuit, which can cause a fire or an electrical shock. In the incident described, the nail plate punctured the NM cable, energizing the vapor barrier and corner bead. This created a dangerous situation that could have resulted in serious injury or even death. The fact that a child was shocked underscores the importance of taking electrical safety seriously and ensuring that all electrical work is performed by qualified professionals. When installing nail plates, it is important to follow the manufacturer's instructions carefully. Nail plates should be installed loosely enough to allow the cable to move freely, but not so loosely that they can easily be dislodged. It is also important to ensure that the nail plates do not come into contact with any grounded objects. If additional protection is needed, there are alternative methods that can be used. One option is to use cable guards, which are plastic or metal sleeves that are installed over the cable to protect it from physical damage. Another option is to run the cable outside of the truss area altogether. This may involve rerouting the cable or using a different wiring method. Ultimately, the best way to prevent electrical hazards is to follow the National Electrical Code, or NEC, carefully and to use good workmanship practices. Electrical contractors should be aware of the potential hazards associated with additional nail plate protection in truss areas and take steps to mitigate these risks. Electrical inspectors should carefully examine these areas during inspections and identify any installations that may be unsafe. Homeowners should be educated about the potential risks and should promptly report any electrical shocks or other electrical hazards. The National Electrical Code Section 300.4 specifies requirements for protecting cables and raceways from physical damage. It emphasizes the need to safeguard wiring methods from potential harm during and after installation. In the context of the question, the concern revolves around non-metallic sheath cable, or NM cable, which is commonly used in residential wiring. When an M cable passes through wood framing members, such as studs or joists, it must be protected from nails or screws that could be driven into the framing. Nail plates are a common solution for providing this protection. They are typically metal plates that are installed over the cable to prevent fasteners from penetrating it. However, the incident described raises concerns about the potential hazards of using additional nail plates in certain situations. Specifically, the authorities having jurisdiction, or ODGs, began requiring additional nail plates where an M cable crosses horizontal furring in truss areas. The rationale behind this requirement was to provide extra protection against drywall installation where screws or nails could potentially come into contact with the cable. However, the incident revealed that these additional nail plates could create a new hazard. In this case, a nail plate was pressed into the NM cable, damaging the insulation and energizing the metal plate. This energized nail plate then came into contact with the vapor barrier and corner bead, making them electrically conductive and posing a shock risk. The fact that a child received an electrical shock highlights the severity of this hazard. The incident underscores the importance of considering the potential consequences of any electrical installation practice. While the intention behind the additional nail plates was to improve safety, the actual result was a dangerous situation. This highlights the need for a thorough risk assessment before implementing any new electrical requirements. In response to the incident, the authorities having jurisdiction rescinded the requirement for additional nail plates in this area. This decision was likely based on the recognition that the potential hazards of the additional nail plates outweighed the benefits. However, the incident raises broader questions about the appropriate methods for protecting an M cable in truss areas. There are several alternative approaches that could be considered. One option is to use cable guards, which are plastic or metal sleeves that are installed over the cable to provide physical protection. Another option is to run the cable outside of the truss area, either by rerouting it or by using a different wiring method. It is also important to ensure that nail plates are installed properly. They should be installed loosely enough to allow the cable to move freely, but not so loosely that they can easily be dislodged. Additionally, nail plates should be inspected to ensure that they are not damaged or corroded. Electrical contractors should be aware of the potential hazards associated with additional nail plate protection in truss areas. They should carefully inspect any areas where an M cable crosses furring and ensure that nail plates do not puncture or contact the cable. If additional protection is needed, alternative methods should be explored. Electrical inspectors should also be aware of the potential hazards of additional nail plates. They should carefully examine these areas during inspections and identify any installations that may be unsafe. Homeowners should be educated about the potential risks of electrical hazards and should promptly report any electrical shocks or other electrical problems. It is important to note that the National Electrical Code, or NEC, is a complex and constantly evolving document. Electrical contractors and inspectors should stay up to date on the latest code requirements to ensure that they are providing safe and compliant electrical installations. The 2008 National Electrical Code Section 300.4 addresses the protection of cables and raceways from physical damage where they pass through framing members. While nail plates are a common method of protection, the incident described highlights the potential for unintended consequences. The authorities having jurisdiction's initial requirement for additional nail plates was likely based on a desire to enhance safety. However, the incident demonstrates that even well-intentioned safety measures can create new hazards if they are not carefully considered. The key takeaway from this situation is the importance of risk assessment in electrical installations. Before implementing any new requirement or practice, it is essential to consider the potential consequences and weigh the benefits against the risks. In this case, the authorities having jurisdiction likely failed to fully appreciate the potential for nail plates to damage an M cable and create an electrical hazard. As a result, they implemented a requirement that ultimately increased the risk of electrical shock. The decision to rescind the requirement for additional nail plates was a prudent one. However, it is important to learn from this experience and to avoid similar mistakes in the future. Electrical contractors and inspectors should be encouraged to report any potential hazards that they encounter in the field. This information can be used to improve the National Electrical Code, or NEC, and to prevent future accidents. The National Electrical Code Section 300.4 D is intended to prevent physical damage to cables and raceways. However, it is not a substitute for good workmanship and careful planning. Electrical contractors should always take the time to carefully consider the specific circumstances of each installation and to choose the wiring methods and protection methods that are best suited to the situation. In some cases, nail plates may be the best option for protecting cables and raceways. However, in other cases, alternative methods may be more appropriate. For example, cable guards can provide a similar level of protection without the risk of damaging the cable. Alternatively, the cable can be rerouted to avoid passing through framing members altogether. The most important thing is to choose a method that is safe, effective, and compliant with the National Electrical Code. The incident described also highlights the importance of electrical safety education. Homeowners should be educated about the potential risks of electrical hazards and should be instructed to report any electrical shocks or other electrical problems to a qualified electrician. Electrical contractors should also be educated about the potential hazards of additional nail plate protection in truss areas. They should be trained to carefully inspect any areas where an M cable cross is furring and to ensure that nail plates do not puncture or contact the cable. Finally, electrical inspectors should be trained to identify any installations that may be unsafe. They should be equipped with the knowledge and skills necessary to assess the risks associated with different wiring methods and protection methods. By working together, electrical contractors, inspectors, and homeowners can help to ensure that all electrical installations are safe and compliant with the National Electrical Code. The purpose of the National Electrical Code, or NEC, is to establish minimum safety standards for electrical installations. Compliance with the National Electrical Code, or NEC, is essential for protecting people and property from electrical hazards. The National Electrical Code is updated every 3 years to reflect new technologies and best practices. Electrical contractors and inspectors should stay up to date on the latest code requirements to ensure that they are providing safe and compliant electrical installations. The National Electrical Code Section 300.4 D is just one of many sections that address electrical safety. The National Electrical Code covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. Electrical contractors and inspectors should be familiar with all of the relevant sections of the National Electrical Code to ensure that they are providing safe and compliant electrical installations. In addition to the National Electrical Code, there are other codes and standards that may apply to electrical installations. For example, the International Building Code, or IC, contains requirements for electrical systems in buildings. Electrical contractors and inspectors should be aware of all of the codes and standards that apply to their work. The authorities having jurisdiction, or ODGs, are responsible for enforcing the National Electrical Code and other applicable codes and standards. The authorities having jurisdiction, or ODGs, may be state or local governments. Electrical contractors and inspectors should work closely with the authorities having jurisdiction, or ODGs, to ensure that their electrical installations are safe and compliant. The National Electrical Code is a valuable resource for electrical contractors, inspectors, and homeowners. The National Electrical Code provides detailed information on how to design, install, and maintain electrical systems safely. The National Electrical Code is available for purchase from the National Fire Protection Association, or NFPA. The National Electrical Code is also available online at the National Fire Protection Association, or NFPA website. Electrical safety is a shared responsibility. Electrical contractors, inspectors, and homeowners all have a role to play in ensuring that electrical installations are safe and compliant with the National Electrical Code. By working together, we can help to protect people and property from electrical hazards. The situation presented highlights the importance of continuous learning and adaptation in the electrical field. The authorities having jurisdiction, or ODGs, initially mandated additional nail plates based on their understanding of the National Electrical Code, or NEC, and perceived safety needs. However, The incident revealed an unforeseen consequence, prompting a re-evaluation of the requirement. This underscores that safety measures should not be static, but rather subject to review and refinement based on real-world experiences and feedback. The electrical industry is constantly evolving with new materials, techniques, and code updates. Staying informed about these changes is crucial for electrical professionals to ensure they are employing the safest and most effective practices. This includes attending training courses, reading industry publications, and actively participating in discussions with peers and code officials. Furthermore, the incident emphasizes the significance of communication and collaboration among different stakeholders in the electrical industry. The electrical contractor who discovered the energized nail plate promptly contacted the authorities having jurisdiction, or ODGs, to report the issue. This proactive communication allowed for a timely investigation and resolution of the problem, preventing further potential harm. Open dialogue between electrical contractors, inspectors, and the authorities having jurisdiction, or ODGs, is essential for identifying and addressing safety concerns effectively. This collaborative approach can lead to a better understanding of potential hazards and the development of more robust safety measures. In addition to technical knowledge and communication skills, critical thinking is also paramount for electrical professionals. The incident involving the nail plate highlights the need to think beyond the immediate requirements of the National Electrical Code, or NEC, and to consider the potential unintended consequences of installation practices. Electrical contractors and inspectors should be encouraged to question assumptions, analyze potential risks, and propose alternative solutions when necessary. This proactive approach can help to prevent unforeseen hazards and to ensure that electrical installations are truly safe.